I'm talking about Redux. I think it's kind of old news, but in my opinion, it's still quite relevant. It's been around for 4 years, and there was actually recently an update release for it. But if you're working at a big company, you might find yourself working on an old project, and you have to learn to use Redux. Or if you're starting a new project, you might decide to use Redux because the benefits that it gives to your projects are still relevant. So it's worth learning something. In my time at Intellect, I've taught approximately 10 people, perhaps more, how to use Redux. And everybody's always like, it's black magic, this is witchcraft, I don't understand, what even is this, like, etc. And somebody that I recently started working with, a recent graduate, I watched them carefully learn Redux, and I tried to figure out what was confusing. And for those of you that know how Redux works, I think that the separation was between dispatching an action and seeing how it changes your store. So my goal today is just to remove one layer of abstraction, show you that it's actually really simple, and maybe help you understand it a little bit better. So Redux, for those of you who don't know, is a predictable state management container for JavaScript applications. You can use it in Node. It is based on something that was made by Facebook and the guys who made React, specifically Dan Abramov. It's based on the Flux pattern, and there are variants of it in other popular front-end frameworks like Angular. One is called NGRX. There's a variant of Flux in Vue, and obviously there's React Redux. So Redux is a standalone thing, and React Redux is what you use to connect the Redux store to your React application. So why do we need to change the way we store state? It's because traditional state management is hard. And often it's because we work with objects. And objects are not pure, and it's difficult to test those objects because it's difficult to set up the test state, and it's difficult to sort of determine how those objects work with each other. Are they mutating each other? Are they doing things that we don't know they're doing? And as you add more models and controllers and views to your application, everything changes everything, and it becomes impossible. So the Flux pattern comes along, and we borrow stuff from functional programming. We say that every single state mutation must leave the previous state, as it were, and provide us with a new state with new changes. A little bit of history about this pattern. It was invented by Facebook as well. They had an issue where when a person had a notification on their page to tell them that something had happened, they would clear the notification and do something else and come back, and the same notification was there later, and they had to clear it again. So they figured out that they could solve this problem by introducing unidirectional data flow. So everything that consumes state in your application only receives that from one place. And there's only one way to mutate state. You dispatch something called an action, which is a plain object, and it has some metadata. And whatever consumes that action knows what to do it and knows how to mutate state. So immediately we have a clear separation of concern. Our view and controller don't need to worry about how to mutate state. All they need to do is tell the dispatcher that something happened. This is like classic event-driven stuff, and it's really effective. So it scales super well as well. As you add more consumers, you still only consume state from one place. So Flux allows for multiple stores, but Redux advises that you don't, because it just becomes very difficult to manage. So just to recap, unidirectional state of flow. Every single state change only has one traceable event. This makes it easier to debug. The action handlers are synchronous, so that makes working with them easier. Inversion of control is like a natural side effect, and the action handlers are pure. They're easy to test as well because they're pure. So what I like most about this is that normally when you test your components in a website, say you were working with like Angular.js, the only way to see that what you did something to your website was to look at the changes in the DOM, which kind of sucks. So now that everything is in the state containers, you dispatch an action, you get a new state, and if it's what you expect, the test passes. Super simple. Cool. So this is how Redux looks. It is not a like word-for-word implementation of the Flux pattern. It is a variant of it, a derivative, and it looks very similar. So each of your components in your React application consumes state that is given to it by the Redux store. The Redux store is given to each component by React Redux, and it's a wrapper over your whole app. So if you want to change something in the state, you call something called an action creator, which dispatches an action. The reason that you need to call an action creator is because an action is a plain object. And if you need to put little information into the action, you need something to create the object to give that information to the dispatcher. So after the action reaches the dispatcher, this dispatcher sends the store, the current state, and the action to the reducer. The reducer knows what to do with the action if it wants to do anything at all, and then it sends the changes down to the components from the store. Cool. So at this point, you might be wondering, what the hell is a reducer? So if you have ever used JavaScript, you might have encountered the map function. We take an array and we call .map on it. There are other implementations of .map like Lodash and Ramda. And what the map function does is accept the function, and then what it gives to that function is every element in the array, one by one, and then it does something with that element, and it gives you a new array, one element for every element that it was given. So if I console.log bigger numbers, I get everything plus 1. Cool. You go. So now we look at reduce. Reduce operates similarly to map, but it accepts two arguments. It accepts a function, and it accepts an original value. I think it's also called the accumulator, I think. I might be wrong. And then the function that you give to reduce accepts the element and the current accumulated value. So if I want to sum all the values in my array, I just add the current element to the sum. And 1 plus 2 is 3. So there you go. And it works in Node as well. Cool. So this is a reducer. And this is like not from the source code for Redux. It is me trying to explain in really simple terms how the reducers work. So somewhere in the dispatch action, there is a collection of reducers. And we reduce over all the reducers, giving each reducer the state and the action. So over here is our reduce function, and there's the current state, which is also what we are using as the accumulator. So then for each reducer, we provide the action and the store. And then in the reducer itself, so in Redux, there's a paradigm of each action having a type. Your actions are not actually valid if they don't have a type, and they're used to tell every single reducer what kind of action is being dispatched. And every reducer only knows how to do something with an action that it wants to do something with. So the key here for me is that every single action goes to every single reducer. So if I know how to do something with the action, then I do something. If I don't know how to do something, then I return the current state. And that is also something that you have to do in Redux. If you don't do that, you'll have lots of trouble in your console. Cool. So just over here, all the talks that I've heard before, I add on to that the Intellect Challenge talk that was just given, and my talk, and then I create a new object. So this is another rule with Redux. if you want to change state, you have to create a new object. It has to be pure, and a nice side effect of this is that it works well with React. If you've ever used React, you know that if you just modify a property on an object, nothing happens, because it doesn't know that the state has changed, and React only re-renders your components when the state changes. Cool. So I want to stop now and show you a demo. I have put like a little spin on the classic to-do MVC, and I want to just show you the app. So I have this whole thing is the app, and each block is a day, and the month is a month component, and then I have buttons, and these buttons come from the to-do components. The first thing you need to do to introduce Redux to your application is to find the React Redux import over here. So you import that, and you import something called combine reduce. Oh shit, this is the wrong file. Okay, my bad. Okay, so I need create store, and I need combine reducers from the Redux library. So every single reducer only works on a small subset of state. So in my app, I've got two pieces of state on my store. I've got the to-do piece, and I've got the action log. I have the action log not because I need it, but because I want to show you that every single reducer receives every single action. And the action log only mutates the action log property on the store, and the to-do only mutates the to-do property on the store. This is like super important. I spent more than like 3 hours figuring this out the first time I did Redux, and it was painful. So then I import the provider from React Redux, and I create the store, and over here I give the provider my store, and I wrap my app in the provider. So the provider is the link between the store and my app. So if I go to app.js and I go to the bottom of the file, you'll see these things. I also like to think of Redux as a glorified observer pattern. So when I finish mutating the store, React Redux tells my components that something has happened. Get the new store from me, and this interface map dispatch to props and map state to props is my interface for connecting myself, my component, to the store and to the action creators. And then I wrap my component in this connect function, which also comes from React Redux, and it feeds the action creators and the properties into my component via the props. So you saw this is the root of my application, but I still have calls to this .props in here because that stuff comes from React Redux. Okay. So let's get on to console.logs. Cool. So when I started the app, the stores all have a blank initial state, and they know how to deal with that. And you see the actions over here are just weird garbage. And what comes back from that is the new store. So let's go to the, what is it called? Event log. Activity log. Sorry, I'm a bit nervous. Okay. So if you follow Dan Abramov's tutorial on Redux, he will tell you to write switch statements for the reducer and for handling all the actions. Eventually, it will become unmanageable. So what we've decided to start doing is to do this. No, to do reducer. And you give a action handler object with a dictionary, and you dictionary into your action handler object to of here. Give an export and dispatch actions, otherwise return nothing. Cool. So I'm going to show that, and now back to the action log. So then I come back here. And put a thing there. So this is just a plain button. I want to show you the button as well quickly. To do. And all I do in to do is tell it to show the modal for the current day so that I can create a new to do. And all that is in, show to do modal, which comes from the show to, damn it. Which comes from my actions, is just this, a plain object. But I need the show to do modal thing is called the action creator. And I need this so that there can be a dynamic nature to the object that I create to consume. Cool. So it's at this breakpoint, and I've logged the action, and I have the stuff there that was dispatched. So the day, the year, the month, and the action. So for this one, all I want to do for every action is log that it happened. So I'm going to disable it quickly. Save that, and then go to the other reducer. Stop that. And put another breakpoint there. Click something else, and you see it's this one as well. So for the same action, both reducers were hit. So that's really important because that ties back to our reducers just being part of a reduce function. Stuff carries on. So I can click on this and complete stuff, and all the while that this has been happening, my console is being spammed because every single action is going to every single place. So this is one part of removing the abstraction. It's just a reduce function. So the next part is, okay, now I've seen how to dispatch actions, and I've seen how to consume them. How do I consume the new store? Nope. So at the bottom here, I have the map state to props. Okay, this is a bad example. Do you guys all understand ES6? Okay, there's a no over there. I'll go to a modal factory, a different one. Cool. So map state to props takes the state after the reducers have done their thing. And I'm using ES6 here to destructure the state. So I'm taking the action log from the store. So we're seeing that I have both the to-do piece of store and the action log piece of store. Components get everything, reducers only get the slice that is pertinent to them. And then I have all the to-dos, and now I want to show you what happens when I get that back. Modal factory. Click on that. No. Okay, 2 seconds. I think I lost my other breakpoint. Click on that, hits the reducer first. Some state mutation happens, hits the other reducer, then comes back, and I have the new state. Bam. Simple. The only black magic now is what happens after I finish mutating state and between when it gets here. That's it. So, like, for me, that really makes everything simpler and easy to understand. I think it's broken. Okay. Most of this code was written when I should have been sleeping, so. Cool, so we've covered this. Take an action to turn on your state. Your application state is always a reduction of what comes from all your reducers. Each reducer only works on a subset of the global state. Just to recap, so wrap the app, then dispatch actions through action creators, don't forget that, and tell your reducer how to handle your actions. So this is the to-do reducer, and I've used Ramda. Redux plays really well with pure functional libraries like Ramda and Lodash, and it also works super well with Immutable.js. I have also read that it can work well with Object.assign, and Dan Abramov actually recommends Object.assign on his site, but I don't like it because you have to know how it works to use it properly. So an example that I have from where it bit me in the butt was I had a piece of state in my store which had an array, and I used Object.assign to change one property on the store, and the array never sort of got seen as a change, and my state never got seen as change, and my component didn't re-render. So with stuff like Ramda, it's much easier to manage just changing small pieces of state because it makes shallow copies of your objects, and because the reference changes while no heavy lifting has been done, React picks it up as an actual change to everything. Cool. So my favorite thing about Redux is that it reduces coupling. If you've ever built a React application with more than 10 components, and if you're familiar with how React wants you to hoist state up to components and then pass down methods to modify that state, you will know why this is gold. So if you have a component at the bottom of your application, like in my case, the to-do component, in order for me to modify state in that component without Redux, I have to pass the function from the app to the month, to the day, to the to-do. It becomes painful very quickly. So now that we can just import the action creators to our application and immediately dispatch actions to our store, we skip a lot of stuff that we didn't need to do. And we all know coupling is bad and high cohesion is good. So I have some best practices here, stuff that has bitten me and stuff that I know. The reducers must always be pure. There is a thing called reducer composition, which I haven't covered here because I don't want to go too deep and lose people. You can, from your reducer, send the action to another reducer and have that sub-reducer deal with a small fraction of the state. This helps you deal with just making sure that things that have similar concerns are kept in the same file and dealt with by the same sub-reducer, even though the state still becomes part of the parent state. There is a paradigm to name each action noun _ verb. So to do add, this helps you create namespaces in a sense. So if you ever need to do something like copy all your actions and duplicate them, it's easy to do. You can just rename them all. And there is a thing called create reducer, which you give an object with all your functions, and it creates the reducer function for you. That's really useful. It helps avoid a lot of the boilerplate that makes Redux painful, because while it is great, there's a lot of pain. For every single action you want to dispatch, you have to change like 4 pieces of code. So we don't always deal with synchronous stuff, and you don't want to bring promises and AJAX calls and that sort of stuff into your store. It's going to mess with the purity of your store. So there are things called Redux. There's a library called Redux Thunk, which is fantastic. And you can use it to create asynchronous actions. So you create an action which wraps dispatch, and you return that function. And then from there, you dispatch the actions as soon as your asynchronous call comes back. There is another library called Redux Saga, which confuses the hell out of me. It uses the New Year 6 stuff to create asynchronous actions, but I've heard it's fantastic. And that's it.